Let us start from the topic theoretical distribution. What exactly theoretical distribution? And in the previous lecture, random variable, what we did, how we are going to continue with random variable. So that is what we are going to do. In the random variable lecture, we discussed two things, okay, about distribution. Not two, actually three types of distributions we have discussed. Three types of distributions we have discussed. What are the three types of distributions? One is discrete distribution we spoke, continuous distribution we spoke, and there is one more distribution also I said, uniform distribution. Uniform distribution means what? Every random variable will have the same probability. That is what? Uniform distribution. Actually, uniform distribution can be part of discrete or continuous, anything. Okay, so as if the uniform distribution is not a different type of distribution, it is comes under discrete or continuous. Fine. So first of all, now you are not supposed to think this distributions, everything is our alien language. My dear, before I enter into the classroom, I was discussing with one faculty, CA final SFM faculty. Okay, I was having word with him, and he was asking some doubts. Okay, 3 days back also he called and asked about some doubts, and today also he called and he was asking some doubts. My dear, a final faculty who is taking SFM, and he is asking the doubts from differentiation. And other day he was asking doubts from covariance, correlation and all. Why I am telling this is, mathematics is there in your FM, SFM, every level you are going to learn. So do not consider this distribution, everything in an alien language. This is not an alien language. First of all, you remember that. Fine. See, being a chartered accountant, they are applying it in SFM, you are going to apply it in SFM, you are going to apply it in FM, okay. But at the same time, if you don't have that mathematical skill in the foundation level, it will affect your FM and SFM for sure. So the way you are giving importance to accounts, the same importance should be given to maths. Paper 3, you should give importance. But most of the people are denying that, nay sir, this is mathematics is not my cup of tea, that's what you are thinking. No way, my dear, mathematics you have to follow. Okay, next year you are going to apply time value of money, derivatives you are going to apply, the applications are going to come. So even the theoretical distribution not directly will come, but this base idea is going to help you out to solve so many problems in your costing or FM somewhere. Okay. Now, so don't think that theoretical distribution is some alien language. It is our own language. That is what you need to understand. First of all, what is theoretical distribution? I'll tell you. In probability, we have done some experiments. Type of experiments are what? Tossing a coin, tossing 2 coins, tossing 3 coins. This is what we have done. Tossing 3 coins, tossing 4 coins. This is what we have done. Am I right, my dear? When I toss 10 coins, fine. Classical definition can be followed. It's okay. When I toss 100 coins or 1000 coins, okay, throwing 2 dice is fine. When they ask you to throw 5 dice, correct? Not ask you to throw 5 dice. So in these cases and all, if I have to find out the probability of getting all 5 sixes, getting probability of 3 5s and 2 sixes, if this way I have to find out, then it can be done only by theoretically. Practically not possible. Am I right, my dear? So we have to do these things. See, mathematics cannot, sir, why should I throw 100 coins? That is what your next question. Logically, you will ask us, sir, why should I throw 100 coins? Mathematically, if you say me, if I can throw 10 coins, I can throw 100 coins also. I should have the solution for 100 coins also. Okay. If I throw 100 coins, I should have the solution for infinite number of coins also. That is what mathematics is all about. You people are happy about 2 coins tossed, 3 coins tossed, 5 coins tossed, 10 coins tossed. But mathematics is not happy with this 2 coins, 3 coins, 5 coins and all. If I can toss 5 coins, why can't I toss infinite number of coins? Is that right, my dear? If I can toss 5 coins, why can't I toss infinite number of coins? So that is what comes under theoretical distribution. Okay. So theoretical distribution comes in theory. There exists only in theory. But I will deny that, because in your institute material the answer is given as only exists in theory. Sometimes it exists in your practical life also actually. So when the MCQ comes, let me answer this question. If this question asked, theoretical distribution exists? Option A, exists only in theory. Practical life. Option C is what? Both. Then you should mark what? Both. What if both option is not there? Which one I should mark? Institute is given as theory, so let us follow theory. Is that right, my dear? Institute is given as theory, let us follow theory. So, this is the way we have to follow. Otherwise, what, I will not say. See, it exists only in theory. But I cannot agree because it exists in practical life also. Can you believe, even, for example, in ICU, hospital ICUs and all, the bed allotments, okay, for example, there are 5 beds only available, COVID time, there are so many beds were not allotted, okay, now in this case, how to approach mathematically? Distribution, this theoretical distribution only will help, so such a wonderful topic it is. So, application real life also there, so, in the option, it based on the other options, we need to take the call. I hope you understood. Only exist in theory is the option we have got, you have to mark it. If both is given, go for both. So don't get confused with should I mark theory or should I mark practical life. Is that right? So as of now, let us understand like this. Theoretical distribution exists only in theory, also in our practical life. I hope now you understand the importance of theoretical distribution. Why this theoretical distribution comes? Because in probability, we have got some limitations. Probability, whatever we learned, they have got some limitations. To overcome the limitations, we are bringing theoretical distribution. Actually, theoretical distribution is part of probability only. This way we can say application of probability. This way we can say it is what? Application of probability, because tossing 100 coins and some questions are asked. So, tossing one coin probability is 1/2. This is basic. And using this probability, I am going to apply it for 100 coins. So, can we call it as application? Yes, of course, we can call it as application. So, differentiation we have, application of differentiation we have. Same way what? Probability we have, application of probability. That is what I am calling it as theoretical distribution. So, such an important topic it is. My dear, I am telling you, probability if I am expecting 6 marks, in theoretical distribution, minimum 7-8 marks. Is that right? Minimum 7-8 marks. We cannot ignore. And out of 7-8 marks, at least 4 to 5 questions without solving anything, just you can answer, mark it. This type of questions only theoretical distribution questions will be asked. So let us not ignore that. So if you are not understanding also, please try to understand. That's what I am telling. I am trying my level best to explain it with some layman's language, in very simple language. Try to follow. Okay, try to follow. If you feel no, theoretical distribution is not my cup of tea in the day 1, that means you will never understand. Okay, now let me go to the part theoretical distribution. In theoretical distribution, what is theoretical distribution? Exist in as well as listen here. Why these requirements? What is the requirement of theoretical distribution? See, whenever there is some limitations, to overcome the limitations, we need to go on, keep on doing something else, right? You understand the meaning of limitations, right? You understand the meaning of limitations. For example, we have limitations of doing CA. To the particular level, one particular level, we are unable to cross CA. Then what we do? We lose ourselves? No. What do? We go for some alternative. We always search and we always go for some other alternative. Do you all agree with me or not, my dear? We always go for some alternative. No one is dependent on one particular career. If not this, let us go to the next. If not this, let us go to the next. Always there is a, because when there is a limitation, always, actually I can say, mother of invention is what? Our requirements, whatever it is, mother of invention. Necessity. Necessity is the mother of invention. In mathematics, necessity is what? Limitation is what? Mother of, not investment, what is it? Inventions. Okay, mother of inventions. Investment is wrong. Okay, mother of inventions. Okay, necessity is mother of inventions, right? Necessity is the mother of invention. Here in mathematics, what? Limitation is the mother of inventions. So, like one particular stage, the people, initially the Pascal, there are Gauss, there are many people who developed this concept. They have got some limitations. So keep on having some limitations. To overcome the limitation, next topics is to come. Sir, beyond this, nothing has come or not? No, many things would have come. but it has not yet come to our system. So it will take time. Is that right, my dear? If I say, you might have heard about the Duckworth-Lewis method in cricket to get the results. Okay, if you might be knowing about Duckworth-Lewis method, there is a method called the DL method, Duckworth-Lewis method. Okay, for example, if rain stops the play, so based on the Duckworth-Lewis method only, they will give the results. So Duckworth-Lewis method, do you think it is some any computer program? No, it is purely based on mathematical formula, probability, sampling, theoretical distribution, everything exists there. Okay, it is not just like that we are not making. So in this theoretical distribution, keep those things aside. Now what is there in our syllabus? Let us talk. So there were some limitations in classical definitions, okay, even in statistical definition. To overcome it, we are bringing this theoretical distribution concept. There are two major divisions we are going to learn. One is discrete, other one is continuous. Of course, yesterday only we spoke about discrete and continuous. Today we no need to discuss about discrete and continuous. Those who did not know discrete and continuous, please once again you watch random variable lecture. There I have explained what is discrete and what is continuous. In a probability distribution, the random variables are integers, we call it as discrete, and non-integers we call it as continuous. Now listen here, my dear. Discrete also I am going to classify into two parts. Discrete I am going to classify into two parts. One is binomial distribution or Bernoulli trial. Then what? Poisson. See, Pascal. What I am writing? Poisson distribution. What is next, my dear? Poisson distribution. One is binomial distribution and other one is Poisson distribution. You may be wondering why discrete has got two methods. When Bernoulli invented some method, why the hell that Poisson also invented one more partition here, right? That question will arise now. Already has got Bernoulli invented something. Bernoulli has given some solution. Why the hell that Poisson has come with some other solution? Because Bernoulli has got some limitations. Binomial distribution has got some limitations. And to overcome that limitation, Poisson overcome with some solution. That's it. Okay, you understand always now, except index number. Index number situation is something different. It's not a mathematical formula. Index number formulas, what you are going to learn is not a mathematical formula. It is based on the requirement, based on the necessity. We are just keep on changing it. But here, any mathematical formula is what, for same thing, if there are 2-3 formulas we have got, for example, correlation. Carl Pearson's also we got, Spearman's also we got. Because what was the limitation of Carl Pearson's? Limitation of Carl Pearson's was that is only for linear distributions, okay, linear, and the next one is it is for quantitative. What if qualitatives are there? Then Spearman came up with some solution. Is that right? Spearman is not a replacement of Carl Pearson. Okay, it's another version of Carl Pearson. That is what we have to say. So, what we have to say is any two people are there for the same thing, for same discrete distribution. We are talking about two people means. So, let us not compare. Okay, because binomial is for a different reason. After the limitations, to overcome the limitations, Poisson also invented one thing. That's it. Okay. Then continuous we'll talk about later. Okay. Now listen here. First let me start from binomial. I want you to write the way I am writing, because and the people who attend the lecture, they only can follow what we are writing. Okay, otherwise they will not be able to follow. I am telling you this. Listen here. Binomial. Bi. What is mean by bi? Two. Bi stands for what? Two. Bi. The meaning is what? Meaning of bi is two. Okay, meaning of bi is what? Two. Fine. Yes. Now, listen here. So we are dealing with two outcomes. Any experiments we are doing, any trials we are doing, and we are going to only have how many outcomes, my dear? Two outcomes. There are only two outcomes. Binomial distribution holding only with what? Two outcomes. That's it. Only two outcomes. What are the two outcomes, you know? Success and failure. It deals with only two outcomes. What are they, my dear? Success and failure. It's obvious, na man. For example, hitting the target. If it is success, not hitting the target is failure. Complement to each other. Okay, clearing CA foundation exam. And what is its failure part? Not clearing CA foundation exam. So anything is there. So any favorable outcome is there. So we have to consider the unfavorable also. So that is what success and failure. That is what success and failure. So we are going to deal with success and failure. And the success we always denote it as P. So what will be failure, my dear? No. 1 minus P. If success is P, means what is failure is? 1 minus P. Sir, I don't want to write 1 minus P every time, sir. So then you can make it as Q. Sir, every time I don't want to write 1 minus P, sir. So it is Q. So you people are thinking P means probability. Actually, the P stands for probability. So it is success probability, I am taking it as P. Failure probability, what should I take? 1 minus P. But every time I cannot have 1 minus P, I don't want to write. So that I am mentioning it as Q. But we are making Q as one of the variable only. One of the parameter. Okay, it is not a parameter. Q is not a parameter. P only the parameter. It's simple. Actually, Q is nothing but what? 1 minus P. So in nowhere I am using Q. Nowhere I am using Q. Wherever I use Q, what is that Q is? 1 minus P. You have to see it as 1 minus P. Don't look at it as P. Sorry, Q. Don't look at it as Q. So that is wrong statement. So success we always denote it as P. Failure we always denote it as Q. 1 minus P. Now, the trials are, in binomial distribution, trials are finite and independent. Finite and independent. Okay. Trials, events. See, when trials are happening, from that trial the result is event or possible outcome, favorable outcome. From where you are going to get? From trial only you are going to get. Trial is nothing but experiment. Okay. So trials are finite and independent. Trials are finite and independent. Of course you understand. Next question you will arise. Then what if dependent? Sorry. What if infinite, sir? If the trials are infinite, then what to do, sir? That's what poison. You understand? That is the reason poison has come. That is the reason poison has come. Is that clear, my dear? So it's what, you know, everything is interconnected. That's what I would like to say. So binomial distribution, two outcomes. One is success, other one is failure. And the binomial distribution, here what is it? Trials are independent. Okay, trials are what? Independent and finite. Trials are independent and finite. Okay, let us go one by one. So since this binomial distribution is a discrete distribution, am I right? What is it? Discrete distribution. The binomial distribution is a discrete distribution. Since it is a discrete distribution, we are going to use the function as probability mass function. When the function is discrete, when the distribution is discrete, the function what we are going to use is binomial mass function. What is it? Probability mass function, which is nothing but PMF. What is it, my dear? PMF. Now, what is PMF? That is probability mass function of binomial distribution. What is probability mass function of binomial distribution? NCX, P power x, Q power n minus x. Please write it down. What is it? NCX, P power x, Q power n minus x. So, what is probability mass function, my dear? It is for binomial distribution. The probability mass function is NCX, P power x, Q power n minus x. Once again, all of you tell me what is probability mass function is? Once again. NCX. This is what probability mass function. This is what Bernoulli trial we call. Okay, Bernoulli invented this method. We call it as Bernoulli trial. Now, what is N stands for? Number of trials. What is P stands for? Probability of success. What is Q stands for? Failure. What is X stands for? Random variable. X is what? Random variable. What is X? Random variable. I'll tell you. One situation I'll give. Tossing 10 coins. Tossing 10 coins. Find the probability of getting 4 hits. The question is what? Tossing 10 coins. Find the probability of getting 4 hits. This is the situation. Tossing 10 coins. Find the probability of getting 4 hits. Now, what is N? 10. Correct? What is N? 10. What is P? 1 by 2. Because I am talking about tossing coins and getting head. What is the probability of getting head?
1 by 2.
So P is 1 by 2. What is Q? 1 by 2. What is X?
4.
That is what our random variable. Why we call it as variable? Variable keeps on changing. Now, why we call it as a variable? I'll tell you. Tossing 10 coins, getting at least 7 heads. At least 7 heads. What is the at least 7 heads? 7 or more than 7. Now tell me, what are the values of X? 7. 4 values of X we are getting. So it is variable, keep on changing. Am I right, my dear? But N is fixed. Is N changing? No. P is fixed. Say yes or no? But X is changing. So I am calling this N and P as parameter. You understand, my dear? Because it is fixed. Is N and P are changing? Is N and P are changing? No, it is fixed. So fixed means we call it as what? Parameter. Fixed thing we call it as what? Parameter. In your school level mathematics you might have learnt parametric constant, etc., etc. This is fixed. Variable concept is different. Parametric concept is different. Parametric concepts are what? Constants are what? Fixed. Variable concepts are constants are keep on changing. So here N and P are what? Parameter. And what is X? Variable. Random variable. What is X is? Random variable. Sir, then you are ignoring Q, sir. Am I ignoring Q? No. Actually, what is? There is no Q only. What is there actually? 1 minus P only we have. So, here we only talk about N and P. We cannot talk about Q. Why? Q is actually in terms of P only. There is no P. There is no Q only here. So, here only 3 alphabets I am using. One is N, P and X. Sir, what is Q? There is no Q. What is instead of 1 minus P, I am writing it as Q. That's it. So, I have to define only 3 things. What is N and P? What is X? N and P is fixed. What is fixed? N and P. So, I am calling it as parameter. And X is what? Random variable. That's it. It's very simple. So, binomial distribution is biparametric. What is binomial distribution is? Biparametric. How the MCQs are asked. This MCQ came 3 to 4 times in the exam. Okay. Which discrete distribution is biparametric? Options are binomial, Poisson, normal, Gauss, something like that it is given. What is the answer? Binomial distribution is biparametric, uniparametric, multiparametric, none of these. What is it? Biparametric. So listen this, that's it. So we do not ignore. See, if you understand the logic or concept behind this explanation, I am again telling you, my dear, you don't worry about MCQs. You can easily give the answers of all the MCQs. So what is X is? Random variable. So here, can we say binomial distribution is biparametric? I hope you understand the probability mass function. Why I am calling it as function? I am using variable, that's what I am calling it as function. Okay, probability mass function. Actually, it is as good as what you know, f of x only. There we used to write f of x, functions and all we used to write f of x. The same thing I am writing it as p of x. Probability function you can take. Okay, I am converting it in terms of x because I keep on changing the values of x. Is probability changes or not? Imam, you please understand one thing. Why this is probability mass function? Don't write. F of x is x plus 1. We generally call it as what? Function. Generally we call it as function. What is f of 1? What is f of 2? F of 3? It goes on like that. values of x changing, values of f of x changing. Am I right, my dear? This is what we call it as function. In function, I'll tell you, it is one-to-one function and all. So it is what we call it as function. Do you all agree, my dear? Same way, if I keep on substituting the values of x, I'll different values of p of x I will get, say yes or no. So I call it as function only again. It's a function. It is a function. So, but it is probability mass function. It's a probability function. It's a probability function. One is general function. That this is what? Probability function. But since it's a discrete distribution, we call it as probability mass function. Since it's a discrete distribution, we call it as probability mass function. Am I right, my dear? PMF. Okay, PMF. So summation P of x is equal to what? Yesterday only we did now. 1. Summation P of x is equal to what? 1. Summation P of x is equal to 1. Is it clear, all of you? Summation P of x is equal to 1. Is that clear? Yes. So what is binomial distribution is? Biparametric. What is binomial distribution is? Biparametric. Okay, that you remember, my dear. So this is first part of binomial distribution. Next, we have to talk about what? Expected values. That is E of x. What is E of x is? Mean. Mean of a binomial distribution. Mean is nothing but NP. Obviously, say formula same, summation fx divided by summation f. That is the formula this. Same formula only. Summation fx divided by summation f. That formula only. So, n into p. This is our mean. Variance, which is nothing but npq. That is np into 1 minus p. Then what is standard deviation is? Root of npq. What is n minus, what is the standard deviation is? Root of npq. Now look at this, my dear. In binomial distribution, very important MCQ, 2 times it came. Mean is always more than variance. Okay. Question will be asked like this: in which discrete distribution mean is always greater than variance? What is it? Binomial. In which distribution mean is always more than variance? Binomial. So what is mean is greater than variance strictly? Okay, mean is always greater than, that is mean always greater than variance. Actually in general also, mean always greater than variance. In general also, mean always greater than variance. So in binomial distribution, mean always greater than variance. This is what M that is expected values. Okay, this is what expected values. Is that right, my dear? Next, mode of binomial distribution is n plus 1 into p. What is mode of binomial distribution? N plus 1 into p. Please, my dear, what is mode of binomial distribution? N plus 1 into p. What is mode of binomial distribution? N plus 1 into p. This is the formula. What is mean? NP. What is mode? What is mean? What is mode? What is P? You know. What is P? What is P? Probability of success. What is N? Number of trials. Am I right, my dear? What is P? Probability of success. What is N? Say loudly. What is P? What is N? What is P? What is N? What is Q? 1 minus P. What is it? 1 minus P. What is probability mass function for P of binomial distribution? NCX, P power x, Q power n minus x. NCX, P power x, Q power n minus x. It's a very simple formula. If you remember this formula, you can easily remember even a plus b whole power 10 also. A plus b whole power 20 also. It's a binomial distribution formula. I'll tell you, look at this. See, a plus b whole power 5. Okay, I'm writing this formula. Look at this. A power 5 plus 5 a power 4b plus 10 a cube b square plus 10 a square b cube plus 5 a b power 4 plus b power 5. As soon as I write it, you will say, sir, you remember a plus b whole power 5 formula also, sir. I can tell you a power plus b whole power 10 also. I can tell you a plus b whole power 20 also. Anything I can say. Even you also can say that. Can you believe that? That is the formula actually. See, this chapter was there in your school level also. 11th standard, in business maths also it was there. Even in science stream students, that is there. But we don't do it actually for the purpose you don't know. Teacher asked me to remember, we will remember. I will tell you what I did. See, this is a power 5, first term. Next, 4, it is a power 4 and b. Total, what is the degree? 5 only. Next will be what? 1 reduce. Cube, square. That is a, I keep on reducing the degree. B, I keep on increasing the degree. Is that right, my dear? Say yes or no. That's what I am doing. A, I keep on decreasing the degree. B, I keep on increasing the degree. Am I right? This is 5C0, 5C1, 5C2, 5C3, 5C4, 5C5. Now, you tell me the formula for a plus b whole power 6. A power 6 plus 6C1, a power 5, b plus 6C2, a power 4, b square plus 6C3, a power 3, b cube plus 6C4, a power 2, b power 4 plus 6C5, a b power 5, 6C6, b power 6. This is the formula. Actually, same thing only here also we have written. This is the same. Okay, fine. It's too late now. This chapter and all you already completed. Now it is not needed. Only to play with your juniors, to play with your siblings, you can use this. But now let me go to this point. Mode of binomial distribution. Mode of binomial distribution. See, in the shorts and all you might have seen in the YouTube or like any Instagram and all shorts and all used to. Some students are doing very fast calculations. We always get inspired. Wow, how fast they are doing. I think they are brilliant. They are scholars. Can you believe those things? You also can do it. And that is there in our syllabus also. But no one is doing it. The purpose we don't know. Even the teacher also doesn't know how to calculate very fast. Even teachers also doesn't know. For example, 6, 3, 4, 5, 6, 7, 2, 8, 9, 4, 2, 1, 6. I have to multiply this. Into 5 I am going to do. I am going to write the answer. See, look at this. 3, 1, 7, 2, 8, 4, 6, 4, 4, 7, 1, 0, 8, 0. This is the answer. If you want to multiply, you can multiply and check it. Yes, listen here. When we multiply, we should come from here, na? I just went from here. Look at this. You may be wondering, wow, this big number. Can you believe you also can do it this fast? Listen here. Okay. $4.89 or look at that. Error or the? Listen here. This is the answer. If I multiply by 5, this is the answer. What you are doing is you are multiplying by 5, but I am not multiplying by 5. I am not multiplying by 5. I don't see it as 5. I see it as 10 by 2. Actually, I divided by 2 and putting extra 0. Correct? I am dividing it by 2 and putting extra 0. That's it. Fine. 50 means what? 100 by 2. Divided by 2, put extra double zeros. You may even see every number this way we can do it. It's not a big deal. This is Vedic calculation. So please understand. Nothing. See, in your school level, you might have, school teachers might have taught you 103 the whole square, 100 plus 3, a plus b the whole square formula and all you might have applied. So we are thinking, why this lengthy method? Calculator we are having just like that we can do. But if you use that method effectively, Calculator is not needed. Orally you can do 103 the whole square. Okay. So there are so many things, my dear. This is what people are selling in the name of what? Vedic mathematics, fast calculation, this, that, so many things they are doing. Okay. Actually everything is there in our syllabus. The only thing is we are not focusing. We are not focusing and we are not interested. But when I sell Vedic calculation, even if I call mathematics tuition, 12th standard mathematics tuition, 15,000 rupees, no one will come. But Vedic calculation, I will teach Vedic calculation, 25,000 rupees, people will come and join with me. But Vedic calculation is nothing but your syllabus, 8th standard syllabus I have to teach for a 12th standard child. And we are ready to spend 25,000. This is what USP, marketing. Okay, this is what marketing. Is that right? Let it be, my dear. So, these things and all, that is what I am very much interested in going to teach for school kids now. Especially 11th standard, 12th standard kids, I want to teach. 9th standard, 10th standard, I have seen the syllabus. Everything is related to your CA foundation syllabus, man. But you people are not using it. All the tricks and hacks are there in your 12th book, 11th book. Okay, let it be. So now mode of a binomial distribution is what? N plus 1 into P. What is N? What is P? What is N? What is P? What is N? What is P? Okay. Now, remember this, my dear. Listen here. If N plus 1 into P is an integer, if N plus 1 into P is an integer, then there are two modes. There are two modes. One is N plus 1 into P, other one is N plus 1 into P minus 1. Therefore, binomial distribution can be what? Bimodal. There can be two modes. There can be two modes. Then, what if non-integers are? If N plus 1 into P is not an integer, then only one mode, which is highest integral value of N plus 1 into P. This is unimodal. So from this what we come to know, my dear? It can be bimodal or it can be unimodal. It can be bimodal or it can be unimodal. Still you are not convinced, I know what exactly this is. Let me give two examples. Let me give two examples. Okay. Example number 1. Are you copying? அதெல்லாம் வரும்பா, வெயிட் பண்ணுப்பா. மீன் போட்டுட்டு இருக்கோம்ல, மோட் போட்டுட்டு இருக்கோம்ல, மோடெல்லாம் முடிச்சுட்டு மீன் மோடெல்லாம் முடிச்சுட்டு திரும்ப வேரியன்ஸ்க்கு வருவோம். Okay, now listen here. Shh. If n equal to 17, p is equal to 1 by 3, okay, p is equal to 1 by 3, find mode. If this is the question, how simple this is, I'll tell you. What is mode formula is n plus 1 into p. What is ns? What is p? 1 by 3. Is it 18 by 3? What is it? 6 is an integer. Am I right, my dear? 6 is an integer. 6 is an integer. Integer means no decimal number. So if it is integer, what I said, my dear, there will be two modes. So definitely 6 is an integer. It's a bimodal. So therefore the modes are 6 and 5. Do you all agree, my dear? The modes are 6 and 5. What is the formula you wrote, my dear? N plus 1 into p and n plus 1 into p minus 1. Do you all agree with me? N plus 1 into p and n plus 1 into p minus 1. The two modes are, therefore there are two modes. There are two modes. Do you all agree with me, my dear? Say yes or no. Now, here there is no problem. Sir, what is the highest integral value? That may be the question, right? I'll come to that point also. For example, 7.79. Approximately equal to what? 8. Approximately equal to 8. That is approximate value. Then integral value is nothing but whatever number before decimal, that is what integral value. Even for example 7.999. What is integral value of 7.999? 7 only. Okay. This is 8th standard logic. There are modulus value, integral value. Okay. Highest integral value. For example, n is equal to 16. P is equal to 1 by 3. Find mode. So what is it? 16 plus 1 into 1 by 3. What exactly we are getting? 5.6666. So therefore, what is mode? Only 5. That's it. It's unimodal. So when it is non-integer, because it is non-integer. Non-integer means what? Highest integral value we take. So therefore, binomial distribution is what, my dear? It can be unimodal or bimodal. Am I right, my dear? It can be unimodal or bimodal. It can be unimodal or bimodal. I hope you understand. Wait, model means what? Mode. Mean, median, mode we do, na? Mean, median, mode, that mode. Say mean formula we did. Mode formula also we are doing. Sir, where is median formula, sir? So median and all, okay, it is average only, okay? Now listen here. What? Equal. That time it is equal. Okay, next. Shh, wait. Now, let me explain the concept of symmetric and skew symmetric. As far as normal distribution is concerned, it's symmetric. Okay, so about symmetric, one full lecture is there. So you don't worry, that bell-shaped curve and all will come. About bell-shaped curve, we have full lecture. So I'll just tell you what is to be remembered. Okay, symmetric. Look at this. This is what bell-shaped curve. In symmetric means what, you know? The meaning of symmetric is mean is equal to median is equal to mode. Okay, in binomial distribution, if it is symmetric, P is equal to Q is equal to 1 by 2. P is equal to Q is equal to 1 by 2. What is it? P is equal to Q is equal to 1 by 2. What is it? P equal to Q equal to 1 by 2. How the questions will be asked, I'll tell you. N is equal to 10. What is N equal to? 10. Find the mean of the symmetric distribution. Find the mean of the symmetric distribution. Now listen here, my dear. N is equal to 10. Find the mean of the symmetric distribution. Symmetric means what? Mean formula is NP. Mean formula is NP. N is given. What is it? 10. But the question is, find the mean of the symmetric distribution. Sir, P is not given, sir. The word symmetric is given. What is the condition for symmetric is? So, 10 into 1 by 2, 5 mean. You understand, my dear? So, this is very important. Okay. P is equal to Q is equal to 1 by 2. So, when it is symmetric, you will get maximum variance. Praveen, happy? What is formula? NPQ. What is variance formula? NPQ. So what will come, my dear? N into 1 by 2 into 1 by 2. What is it? 1 by 4. So what is it, my dear? N by 4. What is maximum variance? N by 4. Question will be asked. Find the maximum variance for 16 observations. Tell me, what is it? These are the questions are coming in the examination. These are the questions only you are avoiding from preparation. Only thing you have to remember this, maximum variance N by 4. The question is what? Find the maximum variance for 16 observations of a binomial distribution. What is the answer? 16 by 4, which is nothing but 4. Am I right, my dear? So where there is maximum variance, we will be also having what? Least variance. N by 8. Least variance is what? N by 8. What is least variance, my dear? N by 8. Now, what is meant by skew symmetric? Symmetric means, see, if you should learn what is symmetric. Symmetric means what? It's a bell-shaped curve. P is equal to Q is equal to 1 by 2, mean is equal to median is equal to mode. This is the property. Your maximum question is going to be what? Why the hell I have to do this? This bell-shaped and all, why it is needed? That's what we discussed in the first chapter. Any business is happening, starts slowly, then it reaches the peak, again there will be a downfall. So anything you do always comes under bell-shaped. For example, in our class also, see, marks, always what slowly what, even there are low level marks also there, slowly increases, it reaches 1 or 2 students, maximum what? Highest number of marks. Average marks will be what? Highest number of people. That is like 19, 20 and all, there will be more number of people. And after 20, 30 and all, what it slowly reduces. Am I right, my dear? Slowly reduces. Anything you take, it always comes under normal distribution. That is the reason we call it as normal. That is what symmetric. So don't take, why should I learn symmetric and all? Actually, in day-to-day life, everywhere we are using, anywhere you go, symmetric. In your family also, it has to be symmetric, then only you can lead the enjoyable life. Okay, that is, all people should be there. People who are criticizing should be there. People who are loving should be there. Okay, but when it comes to your family also, just assume the people who are criticizing will be less. People who are okay, affectionate will be more. People are very much affectionate will be very less. That is your parents. You understand, my dear? That is your parents. So it always like this. The shape is always what bell shaped. Anything you go for it, my dear. Anything you go for it. Traffic, from traffic to anything. Some abnormal condition, COVID condition and all, always reaches peak. Then after you have seen the COVID curve also. Slowly 6-7 patients and reached peak and came down. That is what we called it as first wave. You understand why we call it as waves? You learn the word and all, you have seen waves. First wave is gone. Now second wave is coming. Third wave is coming. This is what they said. Now fourth wave is waiting. This is what they say. Now what does it? Wave means first wave. Reached peak, again came down. Second wave, reached peak and came down. Third wave, reached peak and came down. This is what wave? Correct na? This is the meaning of wave. Wave na dhanapa? Allah. So this is what? Actually normal. Okay, this is what? Normal. Yes, you understand now? Is that clear? And this is what we call as mixed curve. Okay, this is what we call it as mixed curve. So don't think that this is not there in our syllabus or not needed in our day-to-day life. You are applying in day-to-day life. The word wave is nothing but a symmetric distribution. We are using COVID waves, first wave, second wave, third wave. Okay, even tsunami. First wave comes, some part is gone. Second wave comes, third wave comes. Maximum 3-4 waves are coming. And that's it. End of the world. Okay, in 3-4 waves, end of the world. So 2-3 waves is okay, fine. So this is what wave. Wave, actually wave also you see the curve. You see the curve. Wave curve is what? It's also what the shape is normal only. Karina, the wave curve also normal only. Okay, wave na some bend will be there. Is that right, my dear? So that is what. So please do not think that this is not needed in our life or this is nothing to do with our life. It's very much important, symmetric. Next one is skew symmetric. What is it? Skew symmetric. What does skew symmetric means? Which is not symmetric. Symmetric means exactly mean is between, that is both the sides what? Equivalents. But sometimes the curve can be like this, my dear. Sometimes the curve can be like this. Like this. You understand? It is not perfect bell shaped. Okay. There is some, this portion, look at this. This is called skewness. What is this called? Skewness. In statistical language, what you call? Skewness. Some extension. See, this is exactly middle, mean, median mode, and the peak is going this way. Then obviously what the tail will have the shape. Here equally divides, but here it is not equal division. Here also it is not equal division. So what is this actually? What I said is skewness. And what is this? Skewness. Here skewness, one is towards left hand side. The other skewness is towards right hand side. Remember number line. Remember number line. Left hand side is what? Negative. Right hand side is what? So therefore it is negatively skewed. Negatively skewed and positively skewed. Binomial distribution, it can be symmetric, it can be negatively skewed, or it can be positively skewed. It is symmetric when P is equal to Q is equal to 1 by 2. It is symmetric when P is equal to Q is equal to 1 by 2. Binomial distribution is symmetric when P is equal to Q is equal to 1 by 2. Is that clear, all of you? Say yes or no? Okay. Now, so again, what is meant by binomial distribution? What is the other name of binomial distribution? Bernoulli trial. Either we can call it as binomial distribution or we can call it as Bernoulli trial. Why it is called binomial distribution? Because we are dealing with only two outcomes. What are the two outcomes? Success and failure. What are the two outcomes, my dear? Success and failure. What are the two outcomes? Success and failure. Success and failure. Okay, the two outcomes are success and failure. Fine. Now, it's a discrete distribution. Since it's a discrete distribution, we will have a function, and that is called probability mass function. It is what? Probability mass function. So, what is the probability mass function for binomial distribution? NCx, P power x, Q power n minus x. Here, what are the parameters? N and P are parameters. What is x? Variable, random variable. What is x is? Random variable. Now tell me, my dear, binomial distribution is dash parametric. Biparametric, because only there are two parameters, therefore it is biparametric. What is it, my dear? Biparametric. What is mean of a binomial distribution? NP. What is variance of a binomial distribution? NPQ. Is that right? NPQ. Next, what is standard deviation? Okay, there can be how many modes? It can be unimodal or it can be bimodal. It can be unimodal or it can be bimodal. Okay, when it will be unimodal? Non-integer. When it is integer? Bimodal. So when it is symmetric? P is equal to Q is equal to 1 by 2. So what is maximum variance? Least variance? Is that correct, my dear? Yes. Now listen here. Least na kammi pa. 1 by 2 and 1 by 4 no. See, amma. Adu vera mari varum. N by 8 N by 16 acha. No, N by 8 only. Okay. Now let us solve problems from binomial distribution. Are you all ready? It's not about solving, it is about discussing. All the answers you are going to give me. Please listen here. Shh. Yeah. A theoretical distribution does not exist in theory, exist in real life, both B and C. I told you. Probability distribution may be, it can be discrete or it can be continuous. An important discrete probability distribution is Poisson distribution, because binomial and Poisson only the two discrete. Here it is not given, binomial is not there, so Poisson. An important continuous probability distribution is normal distribution, which has not discussed about it so far. Okay. Shh. Parameter is a characteristic of. Very good. The same question we did it in what? Statistical distribution of table. There are sample list, statistic we say, population parameters are population, for population whatever symbols we are using it is called parameters. Please keep quiet. An example of parameter is population mean. Of course, population mean is the example. Next. A trial, somebody was asking me the meaning of trial. I said trial is also called an experiment. Now look at this. A trial is an attempt to produce an outcome which is neither certain nor impossible. You understand the meaning of neither certain nor impossible? Neither certain means what? Should happen. That is not certain. And never happens. Then it is called not, it is not an experiment only, right? Trial. So neither certain nor impossible. The important characteristic of binomial trial is each trial is associated with two possible outcomes. Of course, trials are independent, of course, but trials are not infinite. They are what? Finite. So option D. What is probability mass function? NCX, P power X, Q power. Wait, listen here. Listen here. Random variable in binomial distribution always belongs to whole number. Random variable always belongs to whole number. In binomial distribution, random variable cannot be negative. Random variable cannot be negative. It can be 0, but it cannot be negative. So it is random variable belongs to whole number. You can write the meaning of RV belongs to W as what? Random variable cannot be negative. Now, X is a binomial variable. That's what random variable, right? With the parameters n and p. Then X can assume any whole number between 0 and n, which is inclusive of 0 and n. That is very important, whole number. Sir, what is the difference between B and C? Actually, option B is given as any value between 0 and n. Even 1.1, 1.2 also possible. Is it possible? Because it is discrete, means always it takes integer. And here the variable should be what? Whole number. Now, binomial distribution is never symmetrical, never positively skewed, never negatively skewed. Symmetric when p is equal to 0.5. It is symmetric when p is equal to q is equal to 1 by 2 I said, which is 0.5. Is that right or wrong, my dear? Now next step. எப்பா நீங்க அடுத்தடுத்த சம் போறதா இருந்தா நீங்க போங்க, பட் உங்களுக்குள்ள டிஸ்கஸ் பண்ணாதீங்க. The mean of a binomial distribution with parameter n and p is what? NP. The variance of a binomial distribution, C. Look at it very carefully. Sir, NPQ is not there, sir. 1 minus Q is given. What is 1 minus Q is? P. It is actually NQP is given. What is given? NQP is given. Everything is same only, no? An example of biparametric discrete distribution. Are you able to solve or not now? For a binomial distribution, mean and mode are equal when Q is equal to 0.5. That is given na, mean equal to, median equal to, mode when P is equal to Q is equal to 0.5. My dear, everything is given to you. Entire theory, that's what I said. That introduction covers entire theory. The mean of a binomial distribution is what? Always more than variance. Binomial distribution, there may be one mode or two modes. D, option D. Maximum variance is n by 4. Now come to set B. Are you ready? Take your pencils. Now, what is the standard deviation of the number of recoveries among 48 patients when the probability of recovering is 0.75? Look at this, my dear. What they ask you to find out? What they ask you to find out? Standard deviation. Look at this. Wait. What is standard deviation formula? Root of NPQ. Is n is given? Is p is given? So q is also given. Am I right, my dear? So what is the answer? 3. Now, how you are feeling, my dear, about binomial, that is theoretical distribution? It's very simple. Now, next one. X is a binomial variable with n equal to 20. What is the mean of x known to be symmetric? X is symmetric. 10. Underline the word symmetric. The meaning of symmetric is what? P is 1 by 2. What is mean equal to? 20 into 1 by 2. What is the answer? 10. Now, x b of n comma p. Wait. Wait பண்ணுங்க. Do you know the symbol, the meaning of the symbol? Hey, can you read? What is it? What is mean by this? B of n comma p they are writing na. The meaning is B stands for binomial distribution. Whenever we denote B, that's a symbol, all the equal to poda. That random variable belongs to binomial distribution. That random variable is binomial distribution. Now, x can be in Poisson, x can be in binomial, x can be in normal. If I have to denote where is x, binomial, B, n comma p, why they take n comma p? Biparametric. N and p are parameters, na? That has to be mentioned. Okay, like f of x comma y we write, function we write it as f of x comma y, f of x we are writing univariable. When there are bivariables, f of x comma y we are writing, same way b of n comma p. Now it's a binomial distribution. What would be the greatest variance of 16? Maximum variance formula is what? N by 4. 16 by 4. I want you to find out fourth one, mode of the distribution. If x is a binomial variable, parameter 15 and 1 by 3. Hey, if the given parameter is 15 and 1 by 3, what is mean by that? N is equal to 15, p is equal to 1 by 3. What is the answer? 5 or 5,6? 5.333, therefore it is 5. Non-integer means it is unimodal. Next step. What is the number of trials? So they ask you to find out the value of n. Enma? What is mode formula? Apply பண்ணுங்க. என்ன கிடைக்குது? 16 divided by 3 எவ்வளவு வருது? 5.33. மோடுக்கு நான் ரெண்டு ஆப்ஷன் கொடுத்திருக்கேன்ல, ரெண்டு கேஸ். இது எந்த கேஸ்ல வருது? யூனிமாடல். யூனிமாடல்னா எது யூனிமாடல்? எது மாடல்னு எடுத்துக்கணும் நம்ம? ஹையஸ்ட் இன்டெகிரல் வேல்யூன்னு சொல்லியிருக்கேன்னா, ஹையஸ்ட் இன்டெகிரல் வேல்யூ என்னது? எங்க கனவு கண்டுட்டு இருந்தா ஹையஸ்ட் இன்டெகிரல் வேல்யூ? அத்தியா கனவு கண்டுட்டு இருந்திருக்க. அப்ராக்சிமேட் வேல்யூ, இன்டெகிரல் வேல்யூ பத்தி சொன்ன ஞாபகம் இருக்கா? என்ன சொன்ன? 7.69 ஓட அப்ராக்சிமேட் வேல்யூ என்னது? 7 இன்டெகிரல் வேல்யூ அந்த டெசிமலுக்கு முன்னாடி உள்ள நம்பர் தான் இன்டெகிரல் வேல்யூன்னு சொன்னா கவனிக்கல. நீ கவனிங்க, அப்படியே உலகத்தை அப்படியே மறந்துடாதீங்க, சரியா? மறக்காதீங்க. யா 5. What is the number of trials? What is the number of trials? What they ask you to find out? N. Please wait. What and all given? Having mean and standard deviation. Mean is 3, standard deviation is 1.5. Look at this, please listen here. Mean is 3. Am I right, my dear? Standard deviation is 1.5. So can we say NPQ is equal to 2.25? Say yes or no? Say yes or no? You know what is NP? What is NP? So 3Q is equal to 2.25. What is Q is equal to? 0.75. So what is P equal to? Now substitute here. N into 0.25 is equal to 3. N is equal to 3 by 0.25. 12 is the answer. Am I right? This quick you should do. Next. What is the probability of getting 6 heads if 6 unbiased coins are tossed simultaneously? Look at this. How many coins are tossed? I want everyone should listen here. 6. What is probability of success is? Why 1 by 2? 3. Yeah. It is probability of getting head or a tail, it is 1 by 2 only. So therefore what is Q? 1 by 2. What is X is? 3. What is X is? 3. Now P of X is equal to 3. According to our formula, NCX 6C3 P power X Q power N minus X. Again 3 only. So what is 6C3 is 20 divided by 2 power 6. 20 divided by 64. 0.3125. Am I right, my dear? Say yes or no?
Yes, sir.
This is the way kids do. But legend method I already told you. Whenever there are 50-50% options, whenever 50-50, 1 by 2 is there, I told you to do one thing. How many coins? How many coins? 6 coins. How many needed heads? 63 divided by how many coins? 6 coins na? 2 power 6, because head and tail are the only 2 outcomes. 2 power 6. What is 63 is? Same answer you will be getting. If 10 coins are tossed, find the probability of getting 7 heads. 10C7, 2 power 10. 10, 7. Next. If overall percentage of success in an exam is 60, so P is equal to 0.6 because percentage is given. So P is equal to what? 60 by 100, which is 0.6. Please write P is equal to 0.6. What is the probability that out of group of 4 students, so what is N equal to? 4. At least one has passed. Look at this. Please listen here. What is N equal to? What is N equal to? 4. Please keep quiet and listen here. What is P is equal to? So what is Q is equal to? Now they said probability of at least one passed is equal to 1 minus probability of none passed. Please listen this. Now this step is very crucial because this is basic for any other problem is going to come ahead. In binomial, Poisson, everywhere, normal, everywhere. So listen this. At least one. The meaning of at least one is what? One or more than one. So symbolically, how can I write? Probability of X is that random variable should be one or more than one. Am I right, my dear? This way can we write? Can we write it this way? Yes. So probability of 1 minus more than 1 is what? 1, 2, 3, 4 goes on like that. Okay. Now what is its opposite? 0. See, actually what you know, what could be the random variable when 4 students are writing? None of them passed. 1 passed, 2 passed, 3 passed, 4 passed. The question is they ask you to add all the 4. Instead what I am doing? Actually total probability is going to be what? Always 1. From 1 I remove this 0. So I will get for 4. Na? Either add 4 or from total remove that is remaining thing. Am I right? I hope now you understood why it is probability of none. Now look at this. Symbolically, how can I write? X is equal to 0. You understand? So henceforth, at least 1 means 1 minus x is equal to 0. Okay. Now, so what will come? 1 minus ncx p power x 4c0 is 1. This is also 1. What is 0.4 whole power 4 is? What is 1 minus 0.25? Point? My dear, I am writing all the steps because for your reference only. In the examination, using calculator you can complete everything. Only idea you should know, okay, x value is 0. X value is 0. 1 minus 4c0 is 0. P is 0. Only q power 4 will come. That's it. Directly by using calculator, orally we can do it. Are you getting the idea, my dear? Say yes or no? Next. Sum number 8. What is the probability of making 3 correct guesses, 5 true or false answer type questions? For this also I already given the hint. What is the hint? True or false question, tossing coin question, everything the logic is same. So tell me, my dear, direct answer you can say 5c3 divided by 2 power 5. That's it. Look at this. 5 true or false. It is like, 5 coins are tossed. Getting 3 true options. Getting 3 heads. What is the shortcut I said? 5c3 divided by 2 power 5. That is the answer. So 10 divided by 32. That's all. Now as of now, whatever we did, very simple questions we did. Now set C problems, some problems are going to be very much challenging, and those problems not meant to be attempted in the examination. But I want you to learn these type of calculations. Are you all ready? Very difficult question also I am going to solve now. Very difficult question also I am going to solve now. As far as examination point of view is concerned, if the same problem comes, remember the answer. Otherwise, leave it, because it is going to be time consuming. But I want you to learn each and every sum. I want you to understand each and every sum. But some problems are not meant for exam preparation. Don't think that then why should I learn? Listen here. Today we can learn. If I am teaching the same thing in the month of November or December, I will not teach these concepts only. That time it is not needed. Now it is needed. Because that time people are coming to attend my lectures only to score 50 marks. But now we are preparing for 100 marks. So you should learn this. If it is known that the probability of missile hitting target is 1 by 2, what is the probability that out of 10 missiles fired, at least 2 will hit the target? Please listen here. Very important thing. Please listen this. Here nothing is mentioned whether it is binomial distribution or not. Since I am doing only binomial distribution, we will be assuming, sir, binomial distribution formula only to be applied. In the examination, you may not be knowing which distribution to be applied. Okay? Don't worry, my dear. Actually, this is the limitation of Poisson. This is the limitation of Poisson. So when I do Poisson, you will come to know why I am applying binomial distribution here. Okay? So because now I have not spoken about Poisson, so let us keep as it is. Now as of now, binomial distribution, let us apply. It is known that probability of missile hitting the target is what? 1 by 8. Total how many missiles? 10 missiles. At least 2 hits the target. Please don't write with me. N is equal to 10. Do you all agree? Probability of hitting the target is? So not hitting the target is? Question is what? Probability of at least 2 means what? So what will come, my dear? Wait. What are the random variables? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that right, my dear? So more than or equal to means what? X can be 2, X can be 3, X can be 4, 5, 6. Sir, I have to substitute X is equal to 3, 4, 5. Then after that I have to add everything, sir. Total 8 probability calculation. That's what I said, lengthy. Instead, you can do like this also. X is more than or equal to 2. They ask you to add everything. Instead, what I'll do? 1 minus, I'll remove these two. Which is easier, my dear? Second one is easier. So 1 minus, open the brackets, P of X is equal to 0. This way we write. Plus P of X is equal to 1. Is that right, my dear? Now you understood? So which is equal to 1 minus, what is N is? 10C0. What is P is? Whole power 0. What is Q is? Whole power 10. Now you understood why this is lengthy. 7 by 8 whole power 10 and all you have to calculate. Whole power 9. Listen here, wait. In the examination, please wait. If these type of question comes, 90% of the cases, directly this is what are the options, mark and come. Sometimes what happens, decimals will be given. If it is decimal given and you want to do it means, how to do, I'll tell you, to reduce your time. Okay, first 7 by 8 whole power 9. See, you start from here. Okay, I think you can find out 7 by 8 whole power 9, right? 10C0 is 1 only. 1 by 8 whole power 0 is 1 only. 10C1 is 10 only. 7 by 8 whole power 9, can you please find out now first? Point? That's it. Point? And into 7 by 8. Point? 3? This is 7 by 8 whole power 10. Why I told you to do like this, Otherwise what you will do, by mistake 7 by 8 whole power 10 you will find out. That value you will write. Then after that you will go for 7 by 8 whole power 9 again. So if you do 7 by 8 whole power 9 first, what happens? Only one time you have to multiply 7 by 8, so 7 by. So in one process we can complete both. Otherwise most of the students are doing 7 by 8 whole power 10 first. After that what they do? 7 by 8 whole power 9 again. Instead what to do? Find 7 by 8 whole power 9 first. Then into 7 by 8 you make it 7 by 8 whole power 10 you will be getting. One shot we can do it. Okay, now get the answer. Now use calculator. Point 1 minus also you did. Point 36. Point 362. Have you all got it? Got it. Next. Mark this type of questions, very important type. If X is binomial variable such that, listen here, twice P of X is equal to 2 is equal to P of X is equal to 3. X is known to be 10 by 3. Sorry, mean of X is known to be 10 by 3. What would be the probability X assumes? At most 2 values. At most the value 2. At most the value 2. Listen here. Please. The given condition is twice P of X is equal to 2 is equal to P of X is equal to 3. Am I right? And mean is equal to 10 by 3. Is that right, my dear? At most X value assumes as 2. At most 2 means what? X should be less than or equal to 2. Am I right, my dear? Maximum 2 it can take. What is my X is less than or equal to 2? 0, 1. So I got 3 values of X. So I got this. Now what and all to be found out? N, P, Q. X we have got N, P, Q to be found out from the given information. What is NP is equal to 10 by 3? Keep as it is. 2 times P of X is equal to 2. Can we write it as? What is N is N is given? Number of observations is given? Fine. So, NC2, P power 2, Q power NC3, P power 3, Q power N minus 3. Am I right, my dear? Say yes or no?
Yes.
Now, 1P. Am I right? 1Q. Am I right, my dear? Correct? See, Q power N minus 2 and Q power N minus 3. Here I have got 1Q extra. Here I got N1Q extra. Na? Cancellation means 1Q extra here. Na maninga. See, Q power N minus 2, Q power N minus 3. Where 1Q extra here? See, for example, put N equal to 10, Q power 8, Q power 7, 1Q extra here. Put N equal to 20, Q power 18, Q power 1 extra Q. Any value for N, that is 1 extra Q we have got now. Fine. So, 2 into, what is NC2? N into N minus 1 divided by 2 into 1. I hope you remember. 5C2 means what we write? 5 into 4 by 2 into 1. Consecutive numbers. Now, what is NC3? Oh, sorry, into Q. What is NC3? Into P divided by, say yes or no, my dear. Am I right? Now, tell me what is Q? 1 minus P, na? Q is equal to, what is here? Open the brackets. NP minus 2P divided by 6. Cross multiply. 6 minus 6P. What is NP? Now, 6 minus 10 by 3 is equal to minus 2P plus 6P. 18 minus 10 is 8 by 3. 8 by 3 is equal to 4P. So, therefore, what is P is equal to 8 by 12. 2 by 3. So, what is P is equal to 2 by 3. Therefore, Q is equal to 1 by 3. Before I started this, I told you the most difficult problems and all I am doing. Correct? Of course. And I told you one more thing. You should learn, but when it comes in the examination, you are not supposed to attend because it is time consuming. But you should leave this problem because of time consuming, not because of not knowing. Please understand this. If you want to skip this problem, you should skip this problem only for what? Time constraint. That will give the confidence. It is not that I don't know, so I am skipping. Actually, we lose our confidence. Arey, I know, but still I leave. I don't want this. See, I know this sum. I know how to solve it, but I don't want to do it. See, knowing the problem after that leaving, it's always Gettama. So please remember that. Now, so we got P value, we got Q value, we got X value, everything. Now, P of 0, P of 1, P of 2. So what exactly will come? N value we got? No, na? Oh, sorry. NP is 10 by 3. N into 2 by 3 is equal to 10 by 3. 3 cut. So what is N equal to? So what will come, my dear? 5C0, P power 0, Q power 3 plus 5C1, P power 1, Q power 2 plus 5C2, P power 2, Q power 1. 5C0 is 1. 2 by 3 whole power 0 is 1. 1 by 27. Is that right, my dear? Oh, 5 ah. Why did I take 2 then 3 and all? Now is it right? Yes. 1 by 2, 43. 5C1 is 5. 5 2s are 10. 10 by 2, 43. 5C2 is 10. 10 4s are 40. 40 by 2, 43. 50, 51 by 2, 43. Can you please tell me what is the answer? I am getting 17 by 81. I am getting 17 by 81. All of you please copy this. Next. Assuming that 1/3 of the population is tea drinkers and each of 1000 enumerators, examiners, okay, takes a sample of 8 individuals to find out whether they are tea drinkers or not. How many enumerators are expected to report that 5 or more people are tea drinkers? Fine. Listen here. Let me write one by one. What is n equal to? 8. 1000 enumerators are different. From population we take only 8 samples. So number of observation 8 only. Because among 8 only I am doing. What is number of tea? What is the probability of tea drinkers? 1/3. So his P is 1 by 3. What is Q is? What we have to find out? 5 or more. So is it P of X is? So that is P of X is more than or equal to 5. It is probability of 5 or probability of 6 or probability of 7 or probability of 8. Sir, I can go for 1 minus also, na sir? Same only. 0, 1, 2, 3, 4. Actually, 1 extra you are getting. So, which is simple here? From 5 to 8 you take. So, what will come, my dear? 8C5, P power 5, Q power n minus 5 plus 8C6, P power 4, Q power 2 by 3 power 1. Sorry. Oh no, what I am doing? Is it 8? Sure. 5, 0. Ayyo. 3. What is here? 6, 2. 8C7, 1 by 3 whole power 7, 2 by 3 whole power 1 plus 8C8, 1 by 3 whole power 8, 2 by 3 whole power 0. Now look at this. 2 cube is what? 8C5 is what? 8C5 is nothing but 8C3. 8 into 7 is 7. 8 7s are 56. 56 into 8 divided by 3 power 8. What is 3 power 8 is? 6561? 6561. 8C6 is nothing but 8C2. 8C2 is nothing but 28. 28 into 4. 28 4s are 112. 112 by 6561 plus 8C7 is 8. 8 2s are 16. 16 by 6561 plus 1 by 6561. Now what is 56 8s are? What is 56 8s are? 448 plus 112 plus 16 plus 1. What did you get? 5? 5 7 divided by 6561.
0.08.
Wait, what is the question, my dear? The question is expected to report. What is it? Expected to report. That means they ask you to find out expected value. 0.08? 0.08, what did you get? 0.08? 7? Can you take it as 0.0888? Yes. Now look at this. Therefore, we need to find out expected value. That means NP to be found out 1000 into 0.088. Hey, this is among 8 people. Now I have to convert for 1000 people. What is it? 88. Do you have it in option? Now tell me, my dear, these type of questions, time waste only. But remember, in our regular class, definitely we should do. Okay, definitely we should do. But for the final preparation and all, last minute lectures, I am not going to do it, because if I do fast track and all, I don't know when I don't do it. Okay, but remember, my dear, this one for practice you should do it. Next. Now listen here. Sum number 5. Out of 128 families with 4 children each, how many are expected to have at least one boy and one girl? At least one boy and one girl. Okay, listen here. Out of 128 families with 4 children each, how many are expected to have at least one boy or at least one girl? Look at this. 5th sum, right? Okay. Total how many families we are taking? No. 4 children each. That is what my n. N is equal to 4. What is n equal to? 4. At least one boy or one girl. At least one boy or one girl. So that means, what is P is equal to? What is Q is equal to? Why? Boy or girl, na? So probability of getting boy or girl is 1 by 2. Now listen here, my dear. Wait, listen here. At least one boy or one girl that family should have. Out of 4 children, that family should have at least one boy or one girl. That means all 4 are boys, not possible. All 4 girls, not possible. Am I right, my dear? 3 boys, 1 girl possible. 2 boys, 2 girls possible. Okay, anything is possible. But all 4 boys or all 4 girls, not possible. Do you all agree, my dear? So, what I am doing is 1 minus probability of all 4 boys I am removing. Boys I am taking it as P, plus all 4 girls also I am removing. Say yes or no, my dear? All 4 boys, no boys. What is meant by all 4 are no boys? All are girls. This way only we should implement, na? This way only should give. Now, 1 minus, what will come, my dear? 4C4 plus 4C0, 1 by 2 whole power 0, 1 by 2 whole power 4. Actually, both are one and the same only. 1 minus 1 by 2 whole power 4, 1 by 16 plus 1 by 16. 7 by 8. Now, total how many families? So, 128 into 7 by 8 is what? 1 1? Copied? Listen here, 3-4 times I want you to do each and every sum here. Listen here, theoretical distribution. If you know set A, set B, additional question bank. If 3 are known, will give you at least 6 out of 7 marks. At least means what? All 7 also you can get. 90% of the 90, not even 90, 95% set C type problems we don't expect in the examination. But 95%, 5% contingency is there. Last time kettandangala, okay. Last time vandirukku appadinanike. So idukku munadi kediyadu. Okay. So we cannot ignore this. But remember one thing, my dear, again I am telling you, this is not about attending it in the examination, it is about learning the concept. Fine? So without pressure you should learn. And because of these questions, it should not affect your set A, set B confidence. The way you used to answer. Now, actually you are understanding, but when it comes to calculation, you are feeling low. That should not happen, my dear. Is it actually you are understanding, na? But only the calculations are what? Little bit actually struggling us. Let it be, it's okay, it is possible. Next. Let us do fourth one. If a random variable x follows binomial distribution with the mean as 5, that means np equal to 5, and satisfying the condition 10 times p of x is equal to 0 equal to p of x is equal to 1, what is the value of p of x more than or equal to 1 given that x is more than 0? Look at this. Of course, you are aware. What is P of A given B? Am I right, my dear? What is P of X is greater than or equal to 1 given? So now what will come, my dear? Here A is greater than or equal to 1, B is more than 1. So what will come? P of X more than or equal to 1 intersection X more than 0. Divided by probability of x is more than 0. Do you all agree, my dear? Yes, now, what is the common value between x more than or equal to 1 and x is more than 0? 1. 1 is more than 0 as well as more than or equal to 1. So that is common value only we should take. So x is equal to 1. Probability of x is more than 0. What is mean by that? 1 minus probability of x is equal to 0. Okay, 1 minus probability of x is equal to 0. More than or எதுல ஆமாப்பா இங்கே என்ன சொல்லியிருக்கீங்க? probability of x is greater than or equal to 1. Sorry. Common is probability of greater than or equal to 1. Greater than or equal to 1. Not equal to 1, greater than or equal to 1. What is mean by greater than or equal to 1? Zero as well as 1. Opposite. Okay, 0 and 1. Is that right or wrong? It is wrong. Listen here. What is x is greater than or equal to 1 means? 1 and more than 1. X is more than 0 means? 1. From 1 onwards it will start 1, 2, 3. So it is nothing but x is more than or equal to 1 only. What is x is more than or equal to 1? 1, 2, 3, dot, dot, dot. It is nothing but 1 minus x is equal to 0. If you ask me, both are same only. This is also p of x is more than or equal to 1. What is meant by greater than or greater than 0 means? I am getting 1. Approximately 0.999. Option C. So this is without doing, directly we got it. Next. One of the worst sum I am going to do, all of you listen here. Try to understand. If you don't understand, also not an issue. Fine. If this type of question, if the same question comes in exam, please remember the answer. Again, I am telling you, remember the answer. Nothing wrong in it. I am not going to say everyone is going to understand this. Some people definitely not going to understand. Because so far we have done unbiased dice, unbiased coins. But here, 10 independent rolling of biased die. What is a biased die, you know? Every number will not have equal chance. For example, unbiased means, what is the chance of getting 1? 1 by 6. Chance of getting 2? 1 by 6. Chance of getting 3? 1 by 6. But here unbiased means, there are some particular numbers, they are going to have more chances than other coins. For example, 6 faces. 2 faces may have 2 numbers, 2. So 2 will have more chance as compared to the other options. Am I right, my dear? So this is what biased coin is. Now, 10 independent rollings of a biased die, the probability that an even number will appear 5 times is twice the probability that an even number will appear 4 times. What is it, my dear? Even number will appear 5 times. Twice the probability that even number will appear 4 times. What is the probability that an even number will appear twice, that is 2 times, when the die is rolled 8 times? So, I came to know what is n. n is equal to 8. X is equal to 2, twice, 2 times. Now, I need to find out what is P and what is Q. But the first line, in 10 independent rollings of biased die, the probability that an even number will appear 5 times is twice the probability that even number will appear 4 times. Look at this. All the best. Even number will appear 5 times is equal to twice the even number appears 4 times. Am I right, my dear? Okay. Now, what is P of x is equal to 5? 10C5, because n equal to 10. P power 5, Q power 5. 2 into 10C4, P power 4, Q power 6. Am I right, my dear? Say yes or no? Now, what is 10C5 is? What? Right only, na? What is it? P. Q. Am I right? Yes. Now, 252 P. 2 into, what is 10C4? 210 2s are? 420 Q. Am I right, my dear? 420 Q. Can I write that Q as 1 minus P? Say yes or no? So now, 252, can we cancel these two? Not 7. What is it? 420 divided by 252? 1.67. Okay, 21 la povum pa idu. 21. 12 times, 20 times. 3, 5. So, we can have, what we can have? 3p is equal to 5 minus 5p. So, therefore, 8p is equal to 5. What is p is equal to? Therefore, what is q is equal to? Now, the question is for x is equal to 2. 10c2. 5 by 8. What 8 times? Oh, 8 times. So 8c2, 5 by 8 whole power 2, 3 by 8 whole power 6. Please simplify this. 8c2 is 28. 5 square is 25. 64. What is 3 power 6 is? No, you get it. Use calculator and get it. Point? Point 0? Are you sure? Option A. Yes, this is what biased coin problem. Generally, people doesn't solve these questions. But I'm telling you now, if the same problem comes means, again I'm telling, see, do you think we will have time for solving these questions or see these sums in the examination? Definitely no. I know it. Then why you are teaching us, sir? My dear, there are something, always remember, we should learn. We should learn everything. Then after that we have to ignore something. That is the right way of approach. Any examination. Okay. Unlike board exams, I know these questions 99% will not come. Okay. But it is there in our syllabus, you should know it. Fine. Because this logic will help you to solve other problems. In the so that confidence will give. Okay. Yes. So that's all with our binomial distribution. Binomial distribution is done. And I want you to solve all binomial distribution questions from additional question bank. Okay.